Does anyone here, raise your hands please, believe that it's a good idea, it's a good philosophy to learn from your mistakes? Yeah, I believe that strongly. Who would agree with me? Let's take this a bit further. Who would agree with me that it's a better idea to learn from other people's mistakes? Yeah, that's right. Let them be the fools, right? That's exactly right. Most common mistakes is something that is very, very crucial to the way CARE teaches, the way we educate. What we do is we collect data, we collect information through surveys, through our inspection force, through a number of different avenues. We gather it all, and when we go out and we teach these contractors how to install a roof, or we teach these salespeople how to sell a roofing system, or we teach these architects how to design a roofing assembly, we share with them the mistakes that others have done prior to them so that they won't commit the same errors. Okay, so they're learning from other people's mistakes. And it paves the road. It's like a gold highway for them if they stay on it. And usually after we leave, for a couple of days, they stay on that paved road. But then about 3 or 4 days down the road, they tend to have forgotten everything we mentioned, and they get off on the rut again, and there they go. So most common mistakes, we're going to share that information to you. What is the most common mistakes in the steep slope roofing industry, in the installation sector? Okay? A review of GAF roofing systems. The GAF roofing systems, because we never say a roof. GAF, we'll sell you shingles. We don't do that. Other manufacturers do, and I'll explain this in more depth as we move along. Other manufacturers will sell you a shingle and nothing else. We sell shingle, the underlayments, the leak barriers, the ventilation products, the hip and ridge products, skylight products, low slope components, et cetera, et cetera. And you put all those things together, and they make what we call the GAF roofing system, because it's all designed to work with one another in a certain way, okay? And we'll share that information with you today. Why use GAF? Here's the problem. GAF, typically, just in broad, general, very general terms, we're not cheap. We're what we like to consider ourselves the market price leader, okay? In other words, we're the most expensive stuff out there for a reason. So, if we're the most expensive, there's got to be something different about us. We got to have that Escalade grill. Otherwise, we're just a Suburban, okay? And what we do differently is we manufacture, as I mentioned previously, we manufacture leak barriers, roof deck protectors, okay? Ridge ventilation, power and passive vents, quality shingles, low slope materials, low slope roofing assemblies and systems. Not very many manufacturers do that. We also manufacture skylights. I think there's something missing from here, right? You guys familiar with Canyon Rock? Canyon Rock is missing from here. We manufacture decorative stone veneers. Not very many people do that either, okay? So we are different. We offer a whole selection of products for our customers. We're a solutions-based organization. From the ground up, let's talk about the most common mistakes. What are the most common mistakes? Did you guys know that GAF has, in its employ, 77 roof inspectors scattered throughout the country? Did you guys know that? Got a lot of inspectors out there. And these guys they operate under a separate entity called Roof Protection Services. But again, their paycheck says GAF just like ours, okay? They go out and they inspect all these roofs that are installed. And what we are able to do is formulate all that information and look at all the failures that we're encountering and investigate why the roofs failed, okay? NRCA, National Roofing Contractors Association, takes surveys every couple of years, and we are able to gather where these roofs are leaking from. Various organizations throughout the country gather information. What we've done is collected all that information and formulated what we call the most common mistakes. Today we're going to focus on the top 11 most common mistakes in the steep slope roof, in the shingle roof, okay? Believe me, there's close to 90 out there, okay? But we have time for the 11 most common. And what are these mistakes? Well, what they are the top 11 reasons that a roofing system fails prematurely, okay? And what does that mean? Well, this is a 3-tab shingle. It's a bit weathered. I've been playing with it for a couple of days now. The 3-tab shingle that GAF manufactures has a warranty length of how many years? 25. 25 years. 25 or 30. This particular one is a 25-year shingle, okay? Sovereign or Sentinel. What does that mean? Well, that means to the consumer that if you buy this shingle and you install it on your dwelling or your commercial building, whatever it is, and you install it correctly with all the systems and all the components interacting together the way they're supposed to or designed to, in 25 years, you should plan on replacing this. It doesn't mean it's going to look as gorgeous as it does today in 25 years. In fact, it's going to look horrible, but it's still going to be there, and it's still going to be doing that function it was designed to do. NRCA analysis or surveys have determined that the typical roof in this country, okay, on a single-family home, a house, is replaced every 8 to 12 years. Wait a minute. 12 times 2 is 24, and this is a 25-year shingle. 50% of its life? That's what this stuff is lasting out there before it's being replaced? Does that seem fair? If I sold you a 25-year roof, I'm your roofing contractor, would you be happy with that?
Not at all.
Do you think our customers are happy with that? No, they're not. That's why we're here, folks. That's why CARE exists, because we need to fix this problem, and we can only fix it one contractor at a time. There are 300,000 licensed roofing contractors throughout the United States. The majority of the roofs that fail in this nation that are being replaced in 8 to 12 years, they're failing not because the material is failing prematurely, but because the person who installed it incorrectly, okay? A lot of these roofs, before they're installed, they're already being replaced. The material may be sitting in the driveway. It's going to get installed tomorrow. That roof has already failed because all the materials aren't there, because the wrong materials are there, because the installer has never been trained. There's a number of reasons, and that's what we call the most common mistakes. So we're going to share the top 11 reasons these roofs fail prematurely. The primary #1 reason roofs fail has nothing to do with GAF. We don't make the materials that fail. The material that fails is plywood. Plywood and OSB. You see, when I have a roof and I take off the old roofing material to install a new roof, I must have a nice, smooth, sound place to install my shingles. We call that place the roofing deck, D-E-C-K, the roofing deck. That deck in the United States is typically 1/2-inch CDX plywood or 7/16 OSB. Typically. It varies from place to place. You go down to Miami, it's 3/4 inch. But in general, it's 1/2-inch plywood or some type of a 1/2-inch sheeting. Building code, International Building Code requires, now this is a law, this is not an option, that when I install a sheet of plywood on all 4 sides, 1, 2, 3, 4 sides. By the way, if you're not familiar, this measures 4 feet by 8 foot. Okay, that's a standard dimension. On all 4 sides, I am required by building code, essentially by law, to install a gap that is 1/8 of an inch wide, which is about the thickness of this nail. Okay, that's it, a minuscule little gap. Now, why would we want to do that? Why would we want to have all these gaps all over our roof?
Because the wood will expand.
Wood will expand. What happens in Wayne, New Jersey in the wintertime? What do we do to our doors and our windows? We lock them up tight. I know people that silicone their windows in the wintertime, right? Take that towel and shove it underneath the door. I'm not going to lose any of this precious hot air that I'm paying for. However, I'm in the house, my family's in the house, we're cooking, we're cleaning, we're bathing, we're washing, we're speaking. All those things create moisture. They create humidity. And all that humidity finds its way through the ceiling into my attic space. And when it gets to my attic space, it gets to the bottom of my plywood or my sheeting. And at that point, that sheeting will expand, okay? Buildings are constantly in a state of motion. We call that flux. They're constantly moving. They're expanding, they're contracting, the wind hits them, and your house sways. You guys know the Sears Tower in Chicago? At the very top, that needle sways 3 feet every single day. Yeah, it's a yard from center. You don't feel it, but it's moving. The building is constantly moving because it's so tall and the wind hits it, okay? Same thing with our homes. They don't move 3 feet, but they move, maybe a 1/4 inch or so, okay? So what happens to that plywood that I buttered up nice and tight together in July when I installed that plywood? In the wintertime, when it expands, what happens to it? It actually buckles. Those joints will buckle vertically, okay? They buckle vertically and they apply a pressure to the nail that I installed to secure it. They apply a negative pressure to it. In other words, they drive the nail up from that constant pressure. Those buckles will, they tend to buckle and stay buckled all winter long. They stay that way until we open the doors and the windows in the spring. And then the moisture starts to get evacuated, okay, or expressed, and then the plywood will relax again, back to its original position. It does this every single year. How would you like to be that nail? And every single year, you've got this negative pressure, negative pressure, negative pressure, until at some point, what happens to that nail when the shingles? Pops right through the shingle. Pops right through the shingle, typically between 8 and 12 years. In that example, did the shingle fail? No. The person who installed the plywood failed, which is not always the roofer. Oftentimes it's the carpenter, the framer who framed the building. But that error is actually very visual in the wintertime. You can drive around town here, and especially on steep slope roofs, roofs that are really, really steep, and they've got big masts, you can see something that looks very similar to this. If you look at these little joints here, these little buckles, and you measure them across, they're 8 foot. Every single sheet of plywood has buckled at the seams. How do we correct that? Take the roof off, fix or replace the plywood, and then reinstall the roof. I cannot take the shingle off, set it aside, and then reinstall it. Once it comes off, it's trash, okay? It's trash, it's going to get recycled. So that's the most common mistake, numero uno, number one in the United States and Canada. Number two, installing over a rotted deck. The guys show up to re-roof Mrs. Jones' house. They tear off the existing roof so they can put down a new roof, and they see something like that. They're like, man, football game starts in a couple of hours. What are they going to do? Okay? But that's the number two most common mistake in the United States, is that they tear off a roof, they find rotted lumber, and they don't replace it. They just go right over the top of it. Okay? It's a crime, in my opinion. It is a disservice to themselves, to the industry, and most importantly, it's a disservice to the client. Okay? Because you remember that nail that took 8 to 12 years to pop out of that roof? How many years will that nail last in this thing? First gust of strong wind. First gust of wind in excess of about 40 miles an hour is going to get underneath this shingle. It's going to apply some negative pressure to the whole shingle, and those 4 nails will pop right off. What happens when this tab is lifted? It creates a tunnel. It's literally a wind tunnel. And now we can focus more wind energy in this area, and it just starts popping those shingles off. I mean, it's, you know, once one goes, a whole bunch of them are going to go. Okay? It's a big problem. It's a huge problem in our industry. Again, has nothing to do with anything GAF manufactures. Why do we want to tear off? Tear off has a different name in different parts of the country. Out here, you guys call them rips, or your roofers out here call them rips. And what that means is that I have old roofing material, and I'm going to rip off the old roofing material, dispose of it, so I can install a new roof on top of a clean substrate or a clean deck. Doesn't always happen. In fact, some building codes will allow you 1, 2, 3 roofs upon each other, okay, before you have to legally remove them. The reason they make you remove them at a certain point is because of weight. You put 10 roofs on top of each other, that's a lot of weight, okay? That's a train load of weight on top of your house, and your family's sleeping in there, okay? So anyway, so the building codes require that they be removed, but they don't require they be removed every single time. So a lot of roofers would just roll out shingles over the top of existing roofs. Problem with that is, we don't know what's underneath. In fact, I have an idea what's underneath. Why would Mrs. Jones invite us to the party? Why would Mrs. Jones call us and spend $15,000, $20,000, $30,000 on a new roof? Because she's tired of the color? Or because it's doing what? It's leaking. So if it's leaking, is it fair to say there's going to be some rotted lumber underneath there? It doesn't take a rocket scientist. We are not sending people to the moon, okay? We're protecting a person's most valuable asset. That's it, okay? And so typically, you're going to find rotted lumber in the exact same places on every single home that needs to be re-roofed. This is a valley. A valley is where 2 planes of a roof intersect, okay? A massive amount of water travels or is discharged through that valley. They tend to leak. That's the most common leak in the United States, is a valley waterway. And so, consequently, the lumber is typically rotted along waterways. Another common area, lumber adjacent to gutters. We call this the eave. This entire edge is called the eave of the house. The lumber adjacent to it is typically rotted. Why? Because you get all this debris and leaves from the trees. They clog up your gutter, okay? Water backs up, and so in the wintertime, water and snow is constantly sitting on that lumber. It rots it out. It's got to be replaced. This is what we call a rake edge. A rake edge is the side of a plane that's exposed to the wind. See, when it's raining, on a good day, rain falls straight up and down, straight down, right? But do we have very good days without any wind around here? When it rains, the wind starts to howl. And what happens is that rain turns into what we call wind-driven rain. It starts moving horizontally or at angles. And so if this is my roof right here, this is the rake of my roof, and it's raining, can't rain just kind of find its way in underneath my roofing material? Absolutely. And so therefore, rakes are notorious for being a rotted area, okay? And again, if my roof is rotted and I nail some new shingles to it, it doesn't stand a chance. Those nails will pop right off the first gust of wind, okay? Now, that's not to say that the roof won't pop off during a Category 5 hurricane. That's going to happen, but that's an act of God. I hate to say this, we were just having a conversation in the other room. We look forward to those days. We sell a lot of shingles when that happens, right? Common mistake number 3, not installing drip edge. Drip edge is a piece of metal. It's a metal flashing. I'll get into flashings later on. But essentially what it does is it protects the edges of my roof from 2 things, wind and rain. Okay, I'm sorry, wind and rain. And so if this is the bottom, the eave of my roof, and this is the rake of my roof, okay, we need to install a drip edge here and a rake edge here. We call it a drip over here because water is going to drip off of it. It's a rake edge here because it has a different function here. See, here it's designed to prevent water from touching the lumber. It just drips to the ground or it drips into the gutter. Here, the metal is installed in a different fashion. And this metal, this rake metal, is designed to prevent wind from driving the rain into the roofing assembly. It's got a completely different job. A lot of times, contractors will take shortcuts, and they will not install rake edge or drip edge, or sometimes both. Common mistake number 4, not using leak barriers. What's a leak barrier? Weather watch and storm guard. Weather watch and storm guard. Everyone should have a sample that looks similar to this. Well, maybe not everyone, but you should just pass it around if you have one. This is storm guard. Storm guard or weather watch, leak barriers as we refer to them at GAF land, is a modified bitumen, SPS modified bitumen, self-adhered, impermeable roofing membrane. What the heck did I just say? All right. It's a membrane that when installed, it's got adhesive on the back. When I glue this, I'm going to adhere it to my deck, okay, and I put a nail through it, that nail seals right up. It seals right up. Water cannot penetrate this area. And so what we do is we install leak barriers in critical waterways, critical water paths, areas where we know a lot of water is going to travel, areas that we know are likely to leak. And if we can install this underneath the roof, it's one of those roofing components, part of the roofing system, okay? It'll prevent water intrusion in that area. So that's what we do with our leak barriers. We recommend that they be installed in the eaves in the north. In fact, I can do this better with the next slide. These are the areas where GAF and actually the roofing industry in general recommend the use of leak barriers. Around fireplaces or chimneys, in valleys and waterways, along walls, okay, skylights, pipes, the eaves, the rakes, hips, and ridges, okay? We don't require that they be installed in all of these locations all the time. These locations vary from geography to geography. For example, the reason we install a leak barrier along the eaves is to prevent ice dams, prevent ice from forming on the eaves and getting into our house, okay? Do you need that in Phoenix, Arizona? No, you really don't. You need other things in Phoenix, Arizona, other components, but you don't necessarily need them there. Here's a couple of handsome gentlemen installing our weather watch. Along the eave of the house, we'll typically install 1 or 2 courses, okay? We call that the warm wall. The warm wall is basically the front face of your house, that front wall where the front door is and the windows. That's a load-bearing wall. Inside that wall, the air is warm in the winter, and outside of that wall, it's cold. So we call that the warm-bearing wall. And we recommend that where that wall is, we come in an additional 24 inches on the roof plane and install that leak barrier, okay? And that's to prevent ice dams, and we'll talk a bit more about that later on. We also recommend we install a leak barrier, or weather watch in this case, in the valley. You see how there's a plane of roofing here and another plane coming out towards you here, projecting towards you? That forms a valley, a waterway. Weather watch and storm guard, what's the difference? Granules and no granules, that's essentially it. What we've done is we've taken asphalt, we've modified it chemically to obtain the characteristics of rubber, okay? Rubber has a tendency to self-seal, to stretch and elongate. Remember, our houses are constantly moving, okay? They're constantly in a state of motion. So if I can install this along that area where the two planes are constantly going to be moving around, I need something that'll stretch, okay? I need something that'll seal when I put a nail through it to secure my flashings or my shingles. The weather watch is a granulated surface, which is what you're looking at here. You can't really see the granules, but you kind of get a general idea, right? It's a granulated surface. The storm guard is a smooth surface material. Smooth surface materials are typically sold in the West. Why? Because our roofs over there are like this. They're just, you guys call them baby roofs because they're just so low. We can dance on those roofs. They're so flat. It's also very dry. So we would want to have on steeper roofs and in wetter climates, we'd want to have the use of granules to assist with traction. That's why we do it, okay? And so out here, you ship a lot of weather watch. In the West, we ship a lot of storm guard, okay? So why would I want to buy ours? For a couple of reasons. GAF has, and we're going to get into this in more detail later on. GAF has what we call vertical integration. If you slice this and take a look at all the components that go into it, we manufacture everything that goes into it. The fiberglass reinforcement, we blend our own asphalt, we modify our own asphalt, we make everything that goes into this material. Other manufacturers, in fact, virtually every other manufacturer, sources material from vendors. Somebody blends the asphalt for them. Somebody else will manufacture the fiberglass mat for them. Somebody else will actually put it together for them. And somebody else puts it in a package and sticks their name on it, okay? Can they control the quality of their material if there's 10 different people touching it? Absolutely not. And we can. And that's why ours is better. And that's why ours is typically at a premium, okay? That's our story. Mistake number 5, improperly installed deck protection. We mentioned prior that deck is the plywood structure, okay, the structure of our home. What does a deck protector do? Well, first, what is a deck protector? This is your deck protector. Some of you should have these if you can kind of pick them up and just pass them around. The most common term in the industry for a deck protector is felt, right? We've heard that. GAF makes 15-pound felt, 30-pound felt, shingle mate, and leatherback, okay? We manufacture 4 different products in the felts family, in the roof deck protector family. This particular one happens to be shingle mate, which is the most common that we make and the one that we are actually most profitable at. So we definitely want to push this material. We're going to install some next door. Now, why a roof deck protector? Why do we need this? If the shingle is so great, John, why would I need something underneath it? A couple of reasons. The shingle is made out of asphalt. Okay, asphalt is a petroleum-based product. If I were to take a plywood surface, which is wood, and apply a shingle directly to it, what happens in the summer to this asphalt shingle? It bleeds, it warms up, okay, and it turns into a more viscous liquid. It's not going to, drip off the roof, but it becomes softer. Asphalt has a softening point, okay, and we're going to talk later on about the temperature of this material in the summertime. So if I've got plywood and oil directly above it, what's that plywood going to do to my oil? It's going to leach it. It's going to leach it. It's going to suck it out of it, okay? How much petroleum, how much asphalt did we put into this in the factory? Enough to last how many years?
25.
25 years. So if I've got a plywood substrate or plywood deck, taking asphalt out of my shingle, how many years is it going to last?
Less than 25.
Less than 25 is pretty fair. I don't know. Depends, right? That's the problem, okay? That's the problem. So the building code in every single state of the union, except I believe 3, requires that an assembly, a shingle assembly, have a UL, Underwriters Laboratory, Class A fire rating. And what does that mean? There's Class A, B, C, D, and a bunch of subclassifications. And what that means, it's a standard. It's called a flame spread test. And what they do is they actually put a flame this burning block of wood on a roof at different angles, and they determine how much time before that flame gets into the house. A Class A means that it's going to take the longest amount of time before that wood, that flame gets into the structure. Why is that important? The roof deck protectors that we manufacture, that every manufacturer in general manufactures, are reinforced with fiberglass. Fiberglass is a natural inhibitor to the progress of flame. It's not a fireproofing, okay? Fire will get through it, but it slows the flame down, okay? So what if I take this and I stick it underneath my shingle? Wouldn't that slow down the spread of flame? My shingle is reinforced with fiberglass. So now I've got 2 layers of fiberglass. Some of our shingles have 4 or 5 layers of fiberglass. So you can see that the more fiberglass I have, the more resistant that assembly is going to be to the intrusion of flame, of fire into the home. It's going to get in. It's just not going to get in a flash. Now, what's the theory behind all of this? Well, this is a big oak tree, okay? And it's sitting next to my roof. And the theory that the building department uses, the model they use to create these building codes is this. I got a big, massive oak tree with these big, beautiful horizontal branches growing over my house. Someday in the wintertime, I'm going to get a bolt of lightning, and it's going to strike that tree. Is that possible? Sure. And if a bolt of lightning strikes that tree, can that tree go up in flames? Okay. And if the tree's in flames, can one of those branches fall off on my roof? The building code is not designed to protect my home and keep it from burning. It's designed to give me time to get my family out of the house, okay? That's why we build these assemblies. As soon as I take this out of the picture, all of a sudden, I don't have a UL Class A assembly. I don't even have a UL Class B. I'm down around a C or a D or a subclassification, okay? So that's most common mistake number 5. People simply sometimes don't use any felt at all. They simply go right over the lumber, right over the deck of plywood with a bare shingle. That's not approved by anyone in this industry. But it happens all the time. So a roof deck protector protects our structure from fire. It protects our structure from wind-driven rain. When that wind pushes the rain sideways and it gets underneath my shingles, there's some underlayment there, roof deck protector, to keep that water from getting to the lumber. Ice and weather, we'll share that later on, how the ice dams and the underlayments affect us. Double lap required on slopes of 2 and 12 to 4 and 12. Well, what does that mean? If I've got one of these sheets of shingle mate, that's typically all that's required for you to install underneath your shingle roof. However, if I have a very low slope of 2 and 12 to 4 and 12, the building code requires that I install 2 of them, okay? Why is that? For a couple of reasons. Before I can get into that, I need to show you what this means. Nobody came here, nobody signed up for math today, right? That's what we've got here. So let's do a little bit of very, very simple math. It's not complicated. I'll show you what a slope is. There's my house. And this plane here, it's got an angle to it. We call that a slope or a pitch, okay? We have to have a way to measure that slope or that pitch. We have to measure that for a couple of reasons. One, when the contractor is estimating your job, or Mrs. Jones' roofing project, the steeper it is, the longer it's going to take to re-roof, right? So they have to know how to measure the roofs to determine how much to charge you, because their experience will tell them as the slope increases, it takes more and more time, in general a percentage of more time, to re-roof that building. 2, when the distribution, ABC Supply, Bradco, Allied, whomever, delivers the materials, usually they put them on the roofs. Well, if the roof is too steep, they can't do that. They have to drop them on the ground. So we have to be able to measure the slopes to determine, how is the distribution going to get the material there. If they know it's a 12 and 12, a roof that looks like that, they're not even going to attempt it. They'll simply just go there prepared to drop the material in the driveway. They'll bring the appropriate equipment for that. Number 3, you guys have all heard of this, OSHA, right? We're all familiar with OSHA. Wonderful organization designed for the protection of designed for protection of human life, employees actually in this case. OSHA has all different types of regulations as it pertains to construction and especially the roofing industry. At a certain slope, OSHA requires that we do certain things to protect our employees from falling off the roof. Number 1 cause of death in construction is people falling off of roofs. It's a very dangerous job that we're in. Okay? So we have to be able to determine this slope, these angles here. So how do we do that? It's very simple. Take a measuring tape, you stretch it out 12 inches, and you just lock it. Okay? You take that measuring tape and you set it on the slope, any slope of that house that you want to measure. Okay? And all you have to do is make sure the level is, the measuring tape is level. Okay? Level with the horizon. And so we end up with something, a little line that looks something like that. And that's 12 inches, presumably. And then what we do is we take another measuring tape and we drop it from this point straight down. Okay? And we measure that. How much does that measure? Well, let's see. I can stand back here and tell you that that looks like maybe a 4 relative to the 12, 4 inches. So the slope of this plane is measured or determined to be a 4 over 12. Okay? 4 over 12. As the roof becomes steeper, this distance starts to increase. And so therefore this number starts to increase. You notice that if it's a 2 and 12 through a 4 and 12, it's a very, what we call a low slope roof. It really doesn't have very much pitch to it. What happens with the pitches that are very low, water tends to get off those roofs very, very slowly. And when water moves across the surface of a shingle roof very slowly, it's got time to start looking around for that little nail that's exposed, that little imperfection that the mechanic installed. Shingle mate and leather back are what I personally have coined hybrid felts, hybrid underlayments, because they're not a 15-pound felt and they're not quite a 30-pound felt. They're somewhere closer to the 30s. However, they have a stronger fiberglass reinforcement mat than the 15s and the 30s, so they lay flatter. And roofers love that, okay? They love that. And so they're willing to pay a premium for that material, okay? A deck armor is a synthetic underlayment. It has no asphalt in it. It's made out of polyester, nylon, and a bunch of other chemicals that I'm too ignorant to know about, okay? But essentially, the name of the game with deck armor is that it's big. It's big and it's lightweight, okay? And if I want to cover, and we'll do the math for you next door, if I want to cover a big area and I want to do the least amount of labor possible, I want to put deck armor on my shoulder because it covers 10 squares per row as opposed to, 2, 3, 4 squares per row, okay? Why are GAFs better? Same story as previously, vertical integration. We make the fiberglass reinforcement in this material. We blend our own asphalt. We roll our own rolls, okay? Not every manufacturer can say that. A lot of manufacturers have this stuff sent out and made by another company and just labeled with their name. Vertical integration. We control the process of the manufacturing, therefore we can control the quality of the material. This is a photograph of what we call a dried-in home or a felted home. Why dried in? Because it could rain right now and the rain would just shed off the roof. It won't actually intrude into the home. And so what we've got here, first 2 courses are going to be, in this case, a weather watch, okay? On the eaves, on the rakes, weather watch in the valley, and the balance of the home is actually covered with a shingle mate underlayment, all right? This home is ready to receive the shingles, ready to lay the shingles upon it. Deck armor, you guys have seen this, maybe this photograph before. It's a fantastic product. The biggest problem we have at GAF with deck armor, we can't make it fast enough. We can't get it, okay? Contractors love it. They love it for a number of reasons. One, exposure. Typically, we will allow 30 days, but you can install this on the roof and leave it there for 6 months in writing. Architects and specifiers love that. New construction, they love that because new construction, they build the structure, they install the deck, and then they want to dry in the property. You want to prevent water from getting inside, but they're nowhere near ready to install the roof. That has previously been all we could offer them. The wind gets to this, it tears it up. There's a lot of issues with that. This thing here, the wind's doing nothing to this material, and the sun does nothing to it either. Why do we build roofs? To keep water out, right? Yes, basically from a functional standpoint, that's why we do it. But how do we ensure that we can keep the water out for 25, 30, 40, 50, 60, 70 years? We have to design the roofs a certain way to protect them from these certain forces. And those 2 forces are wind and UV, UV being ultraviolet rays from the sun. The wind and the UV are the most destructive forces out there. They just destroy our roofs, given the opportunity. We try to prevent that from happening during the design phase. This little adhesive strip has a very, very important function. When I install my shingle and I nail it down, okay, my next shingle, if it's a 3-tab, which it would be, is going to sit right on top of those nails, covering the nails, and just sitting right over that adhesive strip. That adhesive strip needs 2 things to bond, to seal or stick to the bottom of this shingle. And that's pressure, just static weight, and it's going to get that pressure just from the weight of the tabs of the shingle, and warmth from the sun. Sun's going to warm up the materials, warm up that adhesive, the weight on that adhesive, and they're just going to glue together. Why do we need that to happen? Well, because our roofs are always on a plane. Let's just say this is a roof here. And when the wind blows, the wind's going to blow at the face of this and do what? Turn upward. It's not going to turn down, is it? It's going to turn upwards because of the slope. Problem is that as it turns upwards, it's hitting the edges of those shingles. And if I can get that, if I can allow that wind, if I create an error during the installation, and I leave a little itty bitty hole, okay, then wind can get in there, and now it's going to focus its strength and acceleration, and it will literally tear this shingle back. It'll tear this shingle back, and directly underneath it and behind it is another shingle, and directly behind and underneath that is another shingle, and another, and so on and so on and so forth. Okay, that's the function of that adhesive strip, to keep those tabs glued down so that wind blows right over the top of them. Okay. We cannot allow wind to get underneath our shingles, because that leads to destructive failure. Once one shingle goes, the rest of them are not very far behind. Okay, so that's the adhesive. Now, this is again another slide showing vertical integration. Okay, we make everything that you see on this slide. We manufacture our own adhesives from asphalt that we blend. Okay, not all manufacturers can say that. Granules. The adhesives are applied to granules. Now the granules that you see, they're a bunch of different colors, every color of the rainbow, I like to imagine, at GAF. Granules are a type of stone. I forget exactly which stone it is. It's not limestone. I'm not quite sure. I don't think it's sandstone. It's one of those stones, right? Anyways, we take those little stones and we break them up into little pieces, like so, tiny little things, and then we coat them in a paint. It's a special paint. All those granules in that wet paint go into an oven. They get cooked, essentially. It's called a kiln. And what happens is that there's a chemical reaction that happens in that process. That wet paint turns into a ceramic. Ceramic is a type of glass. And that's why we can color these itty-bitty granules, brown, red, green, whatever, and 20, 30 years from now, the roof is in horrid condition, but the granules that remain are still red, green, brown. Okay, because that color that ceramic coating is permanent. It does not go away. It's a wonderful thing. You should know that there are 2 manufacturers of granules in North America, and only 2. The big one is 3M. 3M Manufacturing. You guys know 3M, the inventors of the Post-it sticky pad. They make chemicals, they make adhesives, they make granules. And they sell granules to virtually every roofing material manufacturer in the country, except one. Guess who that one is. I can take this remote control here and I can throw it and I can hit the world headquarters of the other company that manufactures granules, ISP. ISP manufactures granules, and they only sell granules to GAF. Okay? Why is that important? Because while Owens Corning and Certainteed and Elk and IKO and Malarkey and all those other companies, and some of them have some pretty good products, are buying their granules from 3M, we're making our own granules. Single source accountability. We can control the quality of the raw materials that go into our materials. Therefore, we can control the quality of the end product, okay? Rendering a better quality material. Now, the granules are just little rocks, and we have to find a way to keep them on the shingle. Otherwise, they'll just fall off. When the wind blows, they fly away. And we do that through the means of asphalt. Asphalt is a petroleum-based material. We all know that, okay? It's directly tied to the price of crude oil. There's nothing we can do about it. As crude oil goes up in the stock market, on the world market, the raw material of our shingle is asphalt. It has to go up because asphalt prices go up, okay? So that's the deal. You know, the price of our shingles is tied to world markets, commodity, crude oil prices. Our asphalt, we blend. We use fillers, we use limestone, we use all kinds of additives, and we blend, like in a big mixer, our own asphalt. Why do we do that? So we can control the quality of our asphalt. We know the chemical composition of that asphalt before it's infused into our shingle at the plants. Other manufacturers can't say that. Other manufacturers will buy their asphalt pre-blended from other vendors throughout the nation. That's a commoditized industry as well. I call that flavor of the week. What's on sale today? OC will say to their suppliers, and they probably choose from 3 or 4 or 5 different suppliers, and whoever is cheapest this week gets that order for 3,300 metric tons of pre-blended asphalt, okay? So then the quality of the shingle that comes out of their factory today cannot be the same tomorrow or next week or last month or last year. Is that accurate? Absolutely, okay? That's not the case for GAF. There's a reason we're more expensive. We control the quality of all of our materials all the time. Now, would you guys agree with me that asphalt is a liquid? It is a liquid. If I put something, right now it's in a solid state, but if I put a little heat to it, it's just gonna melt, okay? So it's a liquid. Liquids inherently have no strength, okay? They're liquids. We have to give the shingle some type of strength to allow it to resist those forces that the wind is constantly applying to it. We have to give it some type of rigidity so that when the sun hits it and warms it up to 200 degrees Fahrenheit, it doesn't melt off the roof. We do that through the use of a fiberglass mat, a fiberglass reinforcing material, okay? I believe, forgive me, I could be misspeaking, it's a non-woven mat that we manufacture in Savannah, or in a couple, and there's another one in Northern California. So we make our own fiberglass mats, and we make them for ourselves, okay? Other manufacturers can't say that. Other manufacturers will buy their fiberglass mats from other vendors, from other manufacturers. Again, you know, I'm over at the IKO plant, and I'm their operations manager, and I'm running short on fiberglass mats. I'm gonna get on the phone to my broker and say, okay, who's got fiberglass mats on sale this week? And here comes the train load or the truckloads of these materials, okay? Single source accountability. We manufacture the mat, therefore we can control the quality of that material. We know when this shingle leaves the factory, it's the same quality today that it was last week, that it was last year, that it will be in 2 or 3 weeks, okay? And that's fantastic for the contractors. Contractors love that about GAF. However, not all contractors know that about GAF. And so therefore, some of these contractors that we haven't gotten a hold of yet, they're scared by the price. Oh, GAF is $3 higher. Forget about them, okay? So we never get a chance to get to those guys. And we're trying to change that slowly. Underneath the fiberglass mat, we have more asphalt. Same asphalt, it's basically a sandwich, okay? And underneath that is what we call the backing surface. It's a small, fine sand we install on the back, we apply to the back of the shingle, okay? Some manufacturers use a talc powder, looks like a baby powder of some type. I don't know if there's benefits or drawbacks, I haven't been educated on that, but I can tell you why we use the sand. During the manufacturing process of this shingle or that shingle or any of the shingles we make in the plants, this shingle is moving at about 100 miles an hour. I mean, it's just moving, okay? Baltimore cranks out 40 squares of shingles a minute. It's flying through that facility. And when it gets to the end of the line, the machines start to bundle them together, or I should say stack them together, excuse me, to form a bundle. Problem is that this asphalt here is still warm when they start getting stacked. So we use this sand back here to separate, one, to cool the asphalt, and 2, to separate this warm asphalt from these granules. So they don't stick together. Otherwise, the roofer gets this on the roof, opens the bundle, he's got one big wad of asphalt and granules, and they're all glued together, okay? That's why we do that. This is critical to understanding the way GAF does business, okay? We categorize our shingles good, better, best. Why? Because this is the way human beings think. We go to Walmart to buy a washing machine. There's a $200 washer, there's a $300 washer, and there's a $400 washer. Am I going to buy for my family the $200 washer? Nuh-uh. I'd hate for my neighbor to come over and see that $200 washer, right? That's why that's how this functions. The good shingle is a good shingle. It truly is a good shingle. It'll last 30 years, 25 years or 30 years, okay? Fantastic material. However, most people want to upgrade. Most people don't want the same thing that their neighbor has on their house. Where do you think Keeping Up with the Joneses came from? Okay? If the Joneses have got these things, these roofs on their home, we're not buying anything from this category. We want to bump up. Okay? And this is where our contractors, we try to train our contractors to focus their attention in this category. Okay? The really good contractors focus their attention here. They don't even offer any of that stuff. And we love them. We love them a lot, okay? Because these are commodity items now. And the definition of a commodity is, I'll give you the definition through the use of an expression, of a scenario. Your fuel tank is empty tonight. You got to go buy gas. There's 4 gas stations on each corner. And assuming we're not in New Jersey, assuming you can actually make a left turn, okay? Which gas station are you going to pull into? The cheapest one. The least expensive. Who cares if it's Shell, Mobil, Arco, or whatever? I care about, right? That's the definition of a commodity. Any product where the only choice you can possibly make is price. That's where these shingles have found themselves because of the industry. Every major manufacturer makes a shingle that looks very similar, and it is priced very similar, sometimes cheaper, okay? And so we don't want to focus any of our time there. GAF doesn't make very much money here. We make money here, okay? And this is what we're pushing. This is what we're selling. And this is how we're training our customers, our clients, our architects and specifiers. Spend your time here. So if you have to reduce your price to Mrs. Jones, you can move over here. Some roofers out there, believe it or not, will walk into Mrs. Jones' living room to give her a proposal for a new roof, and they'll walk in with a price for that. So if my price to you, Mrs. Jones, is $10,000 for the re-roof on your house, and I'm going to offer you a Sentinel shingle, invariably, what are you going to do? You're going to say, you know, that 10 grand, that's kind of, I don't know, that's a lot of money. I'll give you 7 grand, John. I'll give you 7 grand for that job, right? So if I have to take the job, quite frankly, because I'm a business, and if I don't get your work, I've got employees that don't get fed, that go away to the competition. I've got equipment I can't pay for. My family doesn't eat. That's the nature of contracting. So if I have to drop my price, material is one factor of my price. Labor is the other factor of my price. Do you think GAF is going to give him a good guy discount and lower the price of the Sentinel shingle that week? No. The price for the material is the price for the material. So if the material price is stable, what has to drop? Labor starts dropping. Labor starts dropping, shortcuts start happening. And that's when the roofer says, it's a lot of money. Oh man, God, $3 a square foot? Don't really need that. Hell, I've heard that in North Carolina, they don't even use felt. We don't need any of that. And that's what happens. That's what happens, slowly. And that leads to that premature failure. GAF lifetime shingles. A lifetime shingle means exactly that. This shingle is warranted for the life of that home, not the person who owns it, the home, okay? That warranty is transferable one time only, okay? We all know that the average home in North America is gonna flip over, is gonna sell typically every 7.5 years, okay? So if you can transfer that warranty one time, what do you got? You got 15 years, right? So are we gonna at some point replace some roofs for free? Absolutely, but not very many, because not very many homes are owned by the same person for 80 years. Most common mistake number 6, we continue. Improper installation of starter shingle. Starter shingle is what it implies. Before you can start installing shingle, you have to start somewhere. Do we agree? Typically, we start on the bottom of the roof, the eave of the roof, and we have to install what's called a starter shingle. Here's a photograph of an incorrect installation. A very typical installation. Incorrect, yet extremely typical. That's why it's up here, guys. Most common mistake number 6. Of all the mistakes in the country, this is the 6th most common mistake in the nation. And what is this mistake? Before I can start installing my shingle here, I have to protect this edge from the wind, okay? Because the wind's going to get in there and flip it back and start getting underneath all of my shingles, pulling them off the roof. So what I do is I install a starter. This is a starter that's been manufactured by a roofer. I'll show you how he did that. But you see this adhesive strip here? That's the point. If we can get a piece of shingle down here, pre-installed, okay, with adhesive facing out, very much like this adhesive here, okay, then when I install my first shingle, that adhesive will laminate itself to the back of my first shingle. It double reinforces. You see how this adhesive is being transferred, the force, to the bottom edge of that shingle? It reinforces the leading edge of that roof so that when the wind hits it, it can't fold back, it can't curl back. It can if we have a hurricane. It's an act of God. All bets are off. But a 20, 30 mile an hour wind gust should not start tearing shingles off your roof. Okay, they're designed to last, to be able to resist greater wind forces than that. So here's what happens. Here's what happened in this photograph. A roofer will order this shingle for the roof. It's a pretty nice shingle, Timberline 30, right? He'll flip it around. He'll take a knife and he'll cut this piece right here. He'll just cut it off. And by doing so, you notice where my finger is, he ends up with a nice clean adhesive strip, right? This is his starter. He'll use this section as his starter. He'll dispose of the rest of this, okay? Just throw it away. And that's fine. It works fine. But what are the problems associated with that? By the way, they also do it with Sentinel and Sovereign. It's the same process. However, what they'll do is they'll cut from here to here all the way down. And so you end up with a nice clean starter. And then they dispose of these tabs. What are the problems with that inherently? There's a number of problems. Let's go through them one by one. If I take this shingle and I cut those tabs off, I've got to dispose of these. Can I dispose of stuff for free in this country? No, I have to pay for it. It's about $300 a ton, okay? Now, I'm not going to generate a ton of tabs on one roof. However, those tabs over the course of a year add up, don't they? Several tons per year. Additionally, I've got to take a knife, and that blade of that knife costs about $1. And I've got to cut that shingle. And every time I do that, I've got to replace my blades, my knives. $1, not a big deal. But what if they're doing 25 homes a week? There are companies that knock out 25 homes a week. I worked for a company that did 80 re-roofs per week on homes. Do the math, okay? That's $150, $160 just in knives in 1 week. Extrapolate that towards the end of the year. It's thousands of dollars, okay? Worse than all of that, because $1 is cheap, okay? 300 bucks is cheap. Worse than all of that is me, okay? I'm the mechanic on that roof. For every $1 they pay me in wages, they've got to pay workman's comp insurance. The owner's got to pay health insurance, 401k, assuming they get it, all taxes, Social Security, you name it. It's a very burdened expense. So for every $1 I get, the owner of the company's got to pay out like $1.87. How much time am I spending cutting these little shingles? Tremendous amount, a tremendous amount, okay? So manufacturing your own starter is wrong on so many levels. And so one of the best kept secrets at GAF is Universal Starter. Okay, Universal Starter is a product that we manufacture. We sell very, very little of this stuff. And it's kind of shameful. Because in my opinion, every time a truck leaves a DC, leaves a distribution center with shingles on it, there should be a pallet of starter on it. Okay? And what we have found is that once the roofers use our starter, on the roof it's a little easier, right? They'll never buy 3-tab shingles for a starter again. It's a lot cheaper. Again, a piece of this, okay, is price competitive with a Sentinel. But once it's installed, you're saving money because you're reducing your labor. Improper nailing. Mistake number 7, improper nailing. We love those nails. There are right and wrong ways to install them, however. The proper way to install a nail is to simply drive it flush to the plane of the shingle. Okay, we don't want to just mash it in there because that damages the shingle. Flush to the plane of the shingle into, of course, good lumber, lumber that is adequate to support that nail. you notice we have a pretty little nail gun out there. One of the most common mistakes with that nail gun is that I'm the owner of the company. I buy one compressor, and I have 3 nail guns on that roof. What happens when the problem with that scenario is that consequently all of those guns are going to end up with not enough air pressure to fully drive the nail into the roof deck. And so you end up with an underdriven nail. And this could be underdriven by 1/8 of an inch, 1/16 of an inch, or 1/4 inch. It really doesn't make a difference. But the problem is that if that nail is popped up, the next shingle that lays over the top of it is never truly going to lay flat. Okay? And so therefore, the adhesive strip will never seal. And you're creating a little air dam for that wind to come along and rip that shingle right off the roof. Another problem is that, you know, I've got a really big compressor, I don't adjust the air pressure, and I've got just one gun. Well, now my compressor is giving me too much air pressure, and so when I nail drive a nail, it's overdriven. You see this little black fine line right down the middle there? That's representative of the fiberglass reinforcements in this material. This is liquid. It's asphalt. It's a liquid. The only strength that this shingle has is derived from that fiberglass reinforcement. If I overdrive my nail and the head of my nail cuts through the fiberglass, which isn't very difficult to do, I can literally, with 2 fingers, pick that shingle up off the roof with 4 nails installed on it. Okay? If I can do that, the wind can do that as well. Big problem. Another problem, crooked nails. The guys are using that gun and they're just running on that roof, and they're going too fast, and they're not installing the nail at the same perpendicular angle as the plane of the roof. The plane is this way, and they're maybe nailing in this direction. You notice that that's not perpendicular? It's got to be perpendicular. Big problem in the industry. Staples in general just aren't used very much anymore. I don't know very many roofers that use staples anymore. Everyone switched over to nails. High nailing. Every shingle has a nail line of some type, usually white, pink, blue, gray, depends on the manufacturer. And that nail line is representative of where we would like you in a perfect world. Maybe it's asking too much, I don't know. In a perfect world, we'd like you to go ahead and nail your shingle 1/4 inch above or 1/4 inch below that line. It's a 1/2 inch slot. Not very much, is it? Would we agree? It's pretty tight parameters. We do that for a reason. Because if I can put my nail directly on that line, I don't want to damage the desk here. Then when I flip my shingle around, you see this is actually 2 shingles. A timberline is not 1 shingle. It's 2 shingles glued together. See, notice this is one part. These are called the teeth, okay? And on the back, we have the laminated strip that gives the shingle that dimensional quality, okay? And so when that nail is put exactly where it's supposed to be, a couple of functions happen. One is that the nail picks up the weight of this back strip, which is just glued on with adhesive. 2 is that we have this adhesive strip here that now receives pressure, and so it seals with the shingle underneath it, okay? This customer called us and says, hey, GAF, your shingle doesn't work. It's falling off my roof. What's going on? So we sent an inspector out. Here's my nail line. Here are my nails. Okay? It's a problem. It's a huge problem out there. Because what's going to happen is as this shingle warms up, if this nail is too high, it's not distributing the weight of this strip. And so as it warms up, the adhesives start to soften up, and the back of this just falls right off to the ground. Okay? Did the shingle fail? At first look, it would appear so, but quite frankly, what happened is that the installer failed to put the nail where it's supposed to be. Okay? Very common problem. Nail popped up. This is an underdriven nail. So that nail doesn't look like much, but this shingle will never seal. On top of that, it'll leave a small little cavity, and the wind gust can get in there and start to lift and pry that apart. This is correct nailing. When they install the nails correctly, the nail of the top shingle will actually go through the top half of the shingle underneath it. So every shingle doesn't actually have 4 nails, which is common misconception. It has 8. If it says 6 nails in the literature, then it should have 12 nails, okay? They're just installed in 2 separate processes. Common mistake number 8, not doing details in valleys. This valley, this is a valley where two planes of a roof intersect. This has got massive problems. I'm not even going to get into it, but you can tell that that's wrong, right? Absolutely. Let's get into a valley and why is it important. Let's look at a droplet of rain, a drop of water that falls here. What's it do? Travels right down to the gutter. It's a dream. It's a dream of every roofer to have a roof that just would do that. Unfortunately, dreams are not reality. Every droplet of rain that falls between this triangularized area will fall in the valley. The valley discharges the largest percentage of water on the roof, period. The problem is that in the valley, because I have two different planes that intersect, I have to, by design, I have to cut the roof wide open and kind of mend them together, okay? That's what we call a valley detail. And so it's critically important that we do that process correctly, otherwise that roof will fail at that critical waterway. And there's a number of things we do. We use plastic cement or adhesives in that valley. We clip corners of shingles. We keep our nails 6 inches offset from the center of the valley. We use a weather watch or storm guard in that valleyway. It's a lot of things we do, and we're going to show those to you next door, okay? This is a completed valley. It needs to be washed off because the chalk line is still there. But essentially, what we did is we ran these shingles up that plane, and then these shingles up this plane, drew a line right down the center of it, and cut it. Cut every individual shingle tab. This is what's called a closed cut valley. It is the most common valley in the United States. Typically, it's built incorrectly, but it is still the most common valley. They try to reach for that. They don't always quite make it, okay? We're going to build that for you next door and show you what the process is. This is what's called an open cut valley. An open cut valley typically uses some type of a metal flashing, some type of a piece of steel or copper or lead or something to prevent water from getting into the system. These valley metals are very, very common in certain parts of the country. Miami-Dade and Dade County, Florida require open cut valleys on all shingles. In California, this is a very, very lucrative appearance. People pay extra money to have this look over that look. Personally, I think they both function equally well if they're built correctly. This one's a bit more expensive because of that valley metal. Now, the valley metal does not have to be copper as it is here. It looks nice. It is considered a high-grade material, but it's not required. We can use galvanized steel, lead. I've seen coil roofing. There's a lot of different materials out there that can be utilized. This is a very common valley metal, or excuse me, valley detail on high-profile designer shingles. Thick shingles, premium shingles, our lifetime shingles. You see, when a shingle has to go through a valley, it has to bend to go through that valley. Some of our shingles are about this thick. Those things don't bend very well, okay? So when you get to that point, we don't encourage them to bend the shingles through the valley. We encourage the use of a valley metal, so the shingle always lays flat. Most common mistake number 9 is flashing areas. Now, does that look right? This roof was 2 days old when I took that photograph. It's 2 days old. This is a prime example of what not to do, okay? Let's take a look at this shingle here, which we've addressed before. This is a 3-tab shingle. What's the longevity, the expected lifespan of a 3-tab shingle? 25 years. 25 years. What's the expected lifespan of this?
A year.
It depends. It could be a year. Absolutely. You see, the roofing system, the whole assembly, all the parts put together are only as good as its weakest link, okay? The first thing that fails on that roof will cause the entire roof assembly, the entire roof system, to fail and ultimately be replaced prematurely. 99% of roofs that are replaced, the shingles are still in incredible condition. Shingles didn't fail. It's all the accessories, all the flashings typically that fail, okay? So let's look at this. This is plastic cement. My colleague at Osmo mentioned that we have to use mastic or plastic cement in the valleys. We use plastic or plastic cement in a lot of different places in our roofs. But we never, or matrix, exactly. But we never have it exposed to daylight. It can never be exposed to UV. Ultraviolet rays from the sun will attack this petroleum-based adhesive. It's asphalt, that's all it is, a modified asphalt, and it starts to dry it out. It starts to cure it out. How long does that process take? It varies. If I'm in Maine, which is just notoriously treed, right? A lot of trees in Maine, and I've got a fireplace and it's constantly in the shade and I do this, that might be watertight or sealed for 6-7 years. But if I take this exact fireplace, the exact same scenario to Phoenix, Arizona, where there is no trees and there is no shade, and the summers regularly hit 127 degrees, when I was 18, I learned that it got that hot in this world. They sent me over to Iraq, and it was 130 degrees regularly. I was thinking, the hell? What is this, Mars? I didn't know we had thermometers that went that high. But this won't last more than a year or two in that condition because the heat leaches the solvents. It's like an evaporation. The solvents evaporate. We call that flashing off. They leach out of the adhesives. And as it loses those solvents, it becomes more brittle and more rock-like. Okay? It hardens. And it also contracts because we're taking things out of it, so it becomes smaller. It cracks wide open, and guess where the water goes? It's like an invitation, and water will run right in through there. So I've got a 25-year roof installed 2 days ago on Long Island. That'll probably last 3 or 4 years. In 3 or 4 years, this brand new 25-year roof assembly will start leaking. Why did they do this? Because my proposal to Mrs. Jones for this roof was $15,000. She'd already been burned previously by another roofer 10 years ago. She's not going to get burned again, is she? So what she does, she says, I'll give you 10 grand for that job. Take it or leave it. And so he takes it. And in the process, he leaves this. Leaves it at Home Depot. He leaves it at Bradco. He doesn't even buy it, okay? So the flashing goes. The step flashing goes next. Because this is inherently cheaper than all those metals. Now, let's take a look at that and let's contrast it with that. This is actually wood shakes. These are wood shakes. Good observation. We don't see those too often anymore, but it doesn't matter. The focus is here. It's the exact same thing. The detail never changes. Anytime there's a plane of a roof and that plane of the roof is intersected with something that goes vertical, be it a wall, be it a skylight, be it a fireplace, the flashing details around that wall, that fireplace, it's identical. A cricket is an area that diverts water behind a fireplace. Sometimes you have a fireplace on the roof. I'm on the ridge. I'm looking down to the street, and I've got a fireplace this wide in the middle of my roof. Well, all the water from the ridge to the back of that fireplace is just going to splash back there and create a swimming pool. So what we do is we have to have the roofer build what we call a cricket. It's a funny word for a water diverter. It's a little structure that they build, okay, and they raise it above the surface of the roof, and we actually roof it with shingles so that the water goes around that area. We don't want to have water sitting there for too long. The NRCA standard requires that anytime a fireplace or skylight or obstruction is over 24 inches, 2 feet wide, we must have a cricket behind it, okay? Let's look at what this guy did. It doesn't require copper. That's a high-end material, very expensive in today's market, very expensive. This contractor did it. It requires that the weather watch or storm guard go up only 4 inches above the surface of the roof, okay? Because it's expensive stuff. This roofer said, I'm going to go up 2 feet. The weather watch or storm guard is so tacky, it sticks so well, it's not required to be back nailed, to be nailed in place. This roofer did it anyways, okay? The sealant between the weather watch and these are called step flashings, it does not apply. We don't have to seal it because our siding is going to come down over the top of that and do what we call counter flashing. It's going to seal that area. He didn't want to take any chances. He sealed it anyways, okay? Number 10, lack of improperly installed ventilation. The building code and FHA, Federal Housing Administration, require that the last person to work on the structure of a building, the structure of the roof of the building, must be ensure that that property is properly ventilated, okay? Doesn't always happen, but I want to share with you what that means, because that's important. It's key to GAF, because we manufacture Masterflow, ton of ventilation products. So we educate the consumer and the contractor, you must build ventilation into the roofing system in order to obtain a warranty, or just in order to comply with the law, basically, okay, because this is the law. So what is ventilation? Why do we need it? Well, let's take a look at our homes here in Wayne, New Jersey in the wintertime. We close the doors, close the windows, we button up our homes very tightly, okay? So not much air is moving around from outside to inside and vice versa, okay? However, we're still cooking, we're still cleaning, we're still bathing, we're still, speaking, and so we're releasing a lot of moisture into the air. That moisture will work its way up into the attic, where it will condensate, turns into water, okay? Now, we already talked previously about the problem with the plywood, right? Expands and contracts, so that's a whole different issue. There's a lot of issues with moisture entrapped in the attic. If I get water in that area there, mold needs 4 things to grow. It needs water, it needs a dark environment, pretty dark in the attic, right? It needs a warm environment, pretty warm in the attic because all that heat is going in there. And it needs a food source. And the food source can be, drywall, sheetrock, lumber, paint, insulation, doesn't really care. It just eats. And mold, when you realize you have a problem, it's usually too late. It looks something like that. These black areas here, that's mold, okay? Now, mold is naturally occurring. It's around us every single day. It's in this room, it's in the floor, it's in my hair, it's everywhere, okay? Science has identified 50,000 different types of mold spores, okay? Because they're everywhere. They're in our food. Cheese is a type of mold, right? The problem is this type of mold. Science, the medical community, has identified 3 types of mold, and they've got these great big long Latin names. I won't attempt to pronounce them, but there's 3 types of mold that the medical community believes, they're not sure, they can't prove it, but they believe there's sufficient evidence to suggest that should we inhale some of those mold spores, and should they get drawn into our lung, the lining of our lung, they can kind of stick to it and just kind of sit there and fester and grow, and then we end up getting sick, basically a type of lung cancer, okay? That's why ventilation is so huge today, because we have to find a way to get that moisture out of our homes. We must get that moisture out of the house. If we can get moisture out of our homes, then I eliminate water from this scenario. With no water, there can be no mold growth. Does that make sense? So there are additional benefits. Not only are we going to eliminate mold from our home by ventilating the home properly, and I'll show you later what that means, there are also some energy consequences, okay? Who's aware of the energy bill today? Everybody. Doesn't it hurt? I used to write a $35 power bill, a check every month. $35, you believe that? Now it's up to $550 a month. It's unbelievable, okay? So everyone that I know, including yourselves, I'm sure, are concerned with energy. So let's talk about the summers in Wayne, New Jersey, or the New York metro area. Getting pretty warm, aren't they? 20 years ago, were they this warm? No, they were a lot cooler, okay? Al Gore might be onto something with this global warming stuff, and it's starting to affect our industry tremendously, tremendously. A typical day in the summer, 90 degrees outside, which we get here, right? The surface temperature of the roof, the roofing materials, the shingles, can be measured with an infrared thermal heat gun. It costs about $80. Take this little gun, you point it at something, you pull the trigger, it tells you the temperature of that surface. Roof surface temperature on a typical 90-degree day is about 170 degrees Fahrenheit. And what that does is it causes the shingle, the underlayments, the leak barriers, the plywood, the lumber, the installation, the drywall to warm up. They warm up and they do what's called convecting heat. They actually transfer heat through convection into the attic space. And that air in that attic space will warm up. It gets hotter, up to about 165 degrees Fahrenheit. You don't go in your attic in the summer, do you? It's hot. What does hot air do? Hot air doesn't want to be hot. It naturally wants to cool itself down. Hot air, the first thing it does is rise. It's lighter than cold air or cooler air. But when this hot air rises, there's nowhere for it to go. It's entrapped. So it finds a second option. The second option is to migrate into cooler conditioned spaces. Here I am watching Sunday football or Monday Night Football with my air conditioner cranked up, and my air conditioner's got the function of cooling this air, and while this air is being cooled, this air is warming it back up again. It's a cycle. It's a consistent cycle. It just goes on all day long, okay? This home has no ventilation. Let's install the ventilation that the FHA requires, and what is that? 1-300 is the rule. There's more math, okay? It's not tough math, though. The math is, the rule requires that for every 300 square feet, not cubic feet, square feet of attic space, I must have 1 net free square foot of ventilation. In other words, for every 300 square feet of attic, I got to have a 1 square foot hole in my roof to let that air in that area escape. So if I've got a 900 square foot attic, how many feet of ventilation must I use? 3, precisely. Half of that will be on top, the other half will be on the bottom. Keep that in the back of your minds for a second. Let's change the slide and let's look at the benefits. If I install, say, a Cobra ridge vent, or a master flow exhaust fan, or a soffit vent, or a box vent, or any number of those vents that we manufacture, when the hot air rises, it finds an opening, and it will naturally escape into the atmosphere. However, it cannot escape if there isn't another opening down here to prevent fresh air to, permit fresh air to enter. Does that make sense? Air cannot escape if you can't replace that air. It'll just sit there, okay? So I open a hole up here that's how big? 1.5 feet, right? 3 foot, if this is a 900 square foot attic, 3 feet, half of 3 feet is on top, the other half is down here. So I've got 1.5 feet of net-free ventilated space on the ridge. I could use a Cobra ridge vent to meet that standard. And I also open 1.5 feet down the bottom. Problem is on the bottom I have 2 sides to the house. The right side and the left side. So I'm going to divide that 1.5 feet again in half. 3/4 square foot here and 3/4 square foot here. You add those together, you have 3 square feet of net-free ventilated area. What happens is as the hot air rises, it's escaped and it's drawing in air from outside. What's the temperature of the air that's coming inside? 90 degrees. Surface temperature of the roof is the same. It's still 170 degrees Fahrenheit. Ambient temperature is the same. That doesn't change. But the air in my attics got cooled down by 20 or 30 degrees. Okay? It cooled down significantly. Not 1,000,000 degrees, but 20 or 30 degrees is better. But the added benefit is that now it doesn't have to go down. It can simply go back up. This is a natural static process. It just does it by itself naturally. Okay? What happens to all the moisture I have in here in this scenario? The moisture is going to escape. It's going to escape. That's it. If I take moisture out of my attic, I can't have mold growth because there's no water, there's no condensation. One of the easiest way to ventilate a ridge or a house is going to be through the use of one of our Cobra products, whether it be a Ridge Runner, Cobra 2, Cobra 3, a lot of different products out there. Another way is to install one of our attic fans. We have those power attic fans, those solar power attic fans. Those things are wonderful. They work phenomenally well. What these things do is there's a thermostat on them that the installer sets it to, let's say 110 degrees. And when the temperature in here reaches 110 degrees, that fan turns on automatically and sucks air out of the attic. It just literally sucks it all out. Cannot be used in conjunction with a ridge vent, though, because if you do that, then all it's doing is sucking in air from outside. It's just circulating the air in this direction. The air down here never gets touched. So this is what we call an exhaust ventilator. Ventilation has an additional benefit. It prevents or reduces ice damming. Ice damming is notoriously damaging to your gutters, to the fascia of your home, to the edge of your roof. It really damages everything in this entire area and reduces the lifespan of it. And why does it happen? Well, let's take a look at a quick drawing here if I could. There's my house in Wayne, New Jersey, and it's January, which means I have what on my roof? I've got snow on my roof, okay? So if I have snow on my roof, and my wife has her way, which she usually does, the heater's gonna be on, right? I put on 3 sweaters, I'm fine, you know? I don't want to pay $1,000 a month for heating oil, are you kidding me? So these red lines are representative of hot air. Hot air rises, okay, convected air. So let's take a look at, let's suppose the distance from the ceiling to the ridge is about 6 feet, which it'll vary. The steeper your roof, the taller that distance. The lower your roof, the shorter that distance. Let's just say it's 6 feet. Let's take a look at this line of convected heat as it moves through my attic, okay? Do you believe, does anyone believe, or you tell me, when this line of convected heat gets here, is it cold or is it still warm? It's actually going to be cold. It'll still be warm compared to the air outside, but it'll be cool enough that it doesn't really affect the structure. Because that distance, as it travels through that distance, it's cooling down, it's losing its heat energy. Let's take a look at this. When it gets to that plywood surface, is it cold or warm? It's warm. It's still hot because that surface area, I mean, that could be 3 or 4 inches along those eaves. And so what happens? Well, it warms up the plywood, it warms up the trusses and the rafters, the insulation, anything you've got there. It warms up the felt, the underlayments, the leak barrier, and the shingles. And then you have snow that starts to what? Starts to melt. And it melts very, very, very slowly. It melts, it gets down to the edge, and then the cold gust of wind hits it, turns it to ice. And then here comes more water, and more wind, and more water, and more wind, okay? That's how you end up with this scenario. If I can open a hole in my attic and some soffit vents to let in fresh air, then all this air as it gets warm is expressed into the atmosphere. And so therefore, this doesn't happen anymore. It still will happen, but it won't happen to that degree. It's greatly reduced because as the air warms up, there's cold air naturally passing through this area to get out, okay? It tremendously reduces that whole problem there. This is also the reason that we install Weather Watch or Storm Guard in the eaves of our homes. Remember we said that earlier, along the edge? Because if I've got dripping water, melted snow sitting here, moving very, very slowly, it has time to find a nail hole on those shingles. And so if it does, it can work its way into the house and cause a leak. So we use Weather Watch or Storm Guard at those edges so that when the water finds this nail head, it can't get in. It's completely sealed. And that's also the reason we don't install it on the entire roof, because it's just not necessary in the entire roof, okay? As I mentioned previously, an easy way to ventilate is through ridge vent, exhaust fans. These are called static vents or box vents. We manufacture them as well in a number of colors. So there's always a way to ventilate a home. This is an easy way to ventilate the bottom of the roof, or the soffit in this case, to allow air to come in. Problem is, sometimes the homes that we encounter, these have already been installed by the builder who built the home 40, 50, 60, 100 years ago. They're oftentimes way too small. So the contractor needs to run the measurements, run the numbers to determine how many of these they need and what dimensions they need them in, okay? Georgia Tech, U.S. Department of Housing, American Plywood Association, and shingle manufacturers are all saying the exact same thing. Ventilation is required, ventilation is required, ventilation is recommended, ventilation is required. Why? Because of litigation, because of lawsuits. What's going to happen at some point as this litigation thing continues to take off with the mold issues, those lawyers are going to come looking for deep pockets. There aren't very many manufacturers out there with deeper pockets than us. Do we agree? And so what we do here, every one of our publications, every one of our books, every single thing we publish or manufacture says ventilation is required. The only way mold will grow in that home is if there is no ventilation. So that's our disclaimer. If it says ventilation is required and the contractor didn't install it, then that gives us the opportunity to, make sense? What if I've got 3 layers of shingles here, okay? It's not going to cause an increase to the temperature of this air. However, it will cause an increase in the time it takes for these materials to cool down. Anybody ever live on the second story of a 2-story apartment building? No? Or 3-story of the top floor of an apartment building? In the summertime, you come home and it's what in that living room? It's scorching hot.
It's hot. Yeah.
Turn on that air conditioner and you got to leave. Go have dinner somewhere and then come back. And it's still hot. And the sun goes down. And it's 10 p.m. and it's still hot. And it's midnight and it's still hot. Why is that? Even though the sun is gone, there's no more heat being applied to the surface. But all these materials are containing heat. And your air conditioner has to do double time, or double duty, to cool the air in here and cool all these materials. And how does it do that? I mean, sometimes it's 3 or 4 in the morning before you can finally turn off that air conditioner. Problem is that at 7 a.m., what happens? Here comes the sun again, and it starts all over again. So having too many materials here, more than necessary, does actually increase waste usage or waste consumption, energy consumption, just because there's more mass. There's more materials that need to be cooled down that evening. So it's always a good idea to tear that roof off. Hip and ridge, the last problem, hip and ridge. What's the duration of this shingle? What's the life expectancy? This is a 25 or a 30 year. This is a 30-year shingle, 30-year timberline shingle, which means it should last 30 years. If I install a 30-year roof, at the peaks, we call the ridge, or at the hips, the two roofs are going to meet, and we have to cover that with something. We call that a hip and ridge, okay, or a ridge cap. We manufacture TimberTex, we manufacture Pacific Ridge, we manufacture Sentinels. The Grand Sequoia Starter is also a hip and ridge product if you can snap it and cut it, okay? So we manufacture products that are designed to work with our products. What happens if I've got a 30-year roof, it's roofing material, and I'm the roofer and I'm going to save a couple of bucks today, so I buy a 20 or 25-year shingle to install on the ridge. What did I just effectively do to that system? I downgraded the warranty to the weakest link. The lowest factor in that assembly is what? 25 years. So this bundle of material is sitting in my driveway, and this bundle of material is sitting on top. Tomorrow, the roofers are coming to re-roof this house. Simply by looking at those materials, we know the warranty is void. That home has no warranty, simply because of the hip and ridge they're going to use to cover it up, okay? Again, applicator-induced failures. The weakest link in the roofing assembly will determine the lifespan of that assembly. See how rugged that is, how attractive that is? That's what you want to see. You want that attractive appearance, but people will buy a Camelot shingle, which is massively rugged, massively dimensional, and they'll cap it off with this. That's criminal. In my opinion, they should be in jail for that. Come on. I just spent $50,000 for a new roof and you put a $3 bundle of shingle on top of it? Come on. This book, everything we're referring to today is in this book. Every single thing is in this book, okay? This is my Bible. This is where I preach out of. This is not a secret. This is published based on, it's the logo right there, NRCA standards. The NRCA, National Roofing Contractors Association, sets the standards for how these roofs in North America are to be built. We just get their information and put it in our book. That's the standard. We're trying to get people to reach that standard. We're not quite there yet. Some people have reached it. Some people have gone beyond the standard. Very few people have. Most people are still hovering down here somewhere.